Hey, I'd like to welcome Michael Schrage here. Michael, thank you. You've had remarkable insights with me for many decades, but particularly for the book. You took some very, I think, unconventional routes to raise attention to these issues around productive ROI. So thanks for just giving us a few minutes just to put it into context. One of the quotes you have, which is really funny, is, if you swear data is an asset, what's your KPI for return on data? And while the room nods at the slogan, almost no one can point to a disciplined, risk-adjusted metric. So can you walk us through this? Because it's very easy to get caught in the euphoria of the moment, but it's not going to last that much longer if you can't measure it.
Yeah, I'm actually happy to tell the brief origin story there because I do executive ed classes at MIT, and people self-select who are very knowledgeable, very technical, very strategic into the program. And everybody talks about how important data is as an asset. And so there's a consensus on this. And so I became sufficiently cynical that I would ask the class, how many of you believe data is an asset? And of course, everybody's hand went up. And then I would think that's fantastic. So what's your metric? What's your KPI for return on data as an asset? Because you have it for people, you have it for real estate, you have it for capital. So what's your return on asset for data, ROD? Risk adjusted. And almost nobody raised their hands on that. We had somebody from Amazon who raised their hand in that regard. Why do I like that story? I like that story first and foremost because it's true. But the other is there's so many things that organizations take for granted that they have neither the courage nor the rigor to hold themselves accountable for it. And one of the reasons why I've become so interested in KPIs and in a generative AI era, KPAIs, is that we have to figure out a way to use these new capabilities for intelligence to do a better job, dare I say a more intelligent job, of holding ourselves accountable for productivity, efficiency, effectiveness, outcomes, outputs. That's sort of been the focus of my research. And for the most part, it goes pretty well.
So talk about virtuous cycles, because we've always traditionally in the West, I think, gone design, act, time delay, reflect. That's not fast enough for this environment.
No. And it's very, very interesting that you phrase it that way. And I'm going to use a word that I feel a little bit uncomfortable with, which is ontology. How do we categorize these sorts of things? And we look at this as sort of what's the process? What's the data flow? What's the workflow? But if you look at the things that make Amazon, Amazon, or Google, Google, or TikTok, TikTok, Meta, Meta, and yes, OpenAI, OpenAI, there is not just a process. There's a virtuous cycle. There is network effects. Let's go back to KPIs for a moment and KPAIs for a moment. One of the virtuous cycles, and I use a mandala to represent it, is you learn to measure and you measure to learn. Now, you could do those things separately, but it doesn't require much imagination or even much technology to have learning to measure and measuring to learn become a virtuous cycle. One could argue, if I can toss this back to the UK, Cavendish Labs, learning to measure how we improve scientific instruments, improves how we measure. This gives us different insights that we can theorize about, but we need to measure. So this, to my mind, is really one of the most important endowments of AI, generative AI, predictive AI, and indeed agentic AI, is that it doesn't just give us an opportunity to become more intelligent. It gives us an opportunity to design better and more intelligent virtuous cycles, better and more intelligent network effects, better and more intelligent flywheels.
So given that, and given the sort of exponential nature of learning right now, when we started this book, you may have one set of views. Have those views been amplified as we've gone past that time period, or have some of them been sort of evolved and changed?
I think it's all evolved on this. Just to borrow your watch to tell you what time it is, I do agree that there is growth on this. There's an accelerated growth. I would say there's exponential development. And one of the things that I think people have sort of downplayed or underappreciated is the fact not just that generative AI, quad generative AI is improving, but there's a certain interoperability there. We have MCP, model context protocols. We can do composable, compoundable, plug and play intelligence. And sometimes these things are accretive and sometimes they're multiplicative. But the key thing is, to my mind, that there are certain emergent behaviors that materialize like a phase state, going from ice to water to steam, that you can't necessarily anticipate because the physics of deep learning and neural nets isn't as well understood as the physics of atoms and molecules. So we're really discovering intelligence as a novel phenomena. In fact, one of the arguments that I have is, to what extent will next generation LLMs, or if you're an Ela Kuhn kind of guy, world models evolve as a function of better understanding of, I'm hearing in the background, animal intelligence versus human intelligence, So I think what we're seeing is a fundamental revisit of what does intelligence actually mean. If you were to ask me what my single biggest surprise about the success of LLMs has been, it's that, and just to date myself, I studied expert systems under Donald Mickey, who was in Bletchley Park under Turing. Okay, so I had a pretty good core understanding of these things. If you were to have told me at that time that, in fact, pattern matching could have the power and force that it did, as opposed to reasons and rules, I would have said, well, that's nice, but the Turings of the world, the geniuses, have a different view of this. But in my view, the reality is patterns get you a hell of a long way there. And when we figure out how to have patterns for patterns and rules for patterns and patterns of rules, I think we're going to see another explosion of emergent capability.
It's particularly true because spatial information is so much more powerful than binary or linear view of the world.
Absolutely.
So vectorization is such a powerful engine to almost Crick and Watson, the sort of landscape that we work in.
But it's funny that you say that, because what did Crick and Watson do? As much as they had a great understanding of chemistry, how they got their Nobel Prize was they built models based on X-ray crystallography from the Rosalind Franklins and the Chargaffs and the Maurice Wilkins of the world. So there was very much that kind of representational, dare I say, multimodal aspect of these things. Even, back to LeCun again, even within the physics or biophysics and the chemistry of what made DNA work inside cellular structures. But, I don't think you picked DNA by accident for another reason, because DNA represents what? A pattern. It's arguably one of the most recognizable patterns in the world. So is it possible, is it probable that we could have had a, dare I say it, Watson and Crick LLM or SLM, do very interesting work in the future of bioinformatics? I would say yes, because life and chemistry are very much a function of patterns as reasons.
I agree. Stretch out a year from now, what do you see as the biggest traps we're going to fail in outside what I call adaptive measurement, or lack of?
That is a great question. So I'm going to steal here. We talked about Watson and Crick as Nobel laureates. I'm going to steal from another couple of Nobel laureates, Kahneman and Thaler, thinking fast and slow, behavioral economics. I think human beings, especially smart human beings, like taking shortcuts. The single biggest pathology and dysfunction I see in my exec ed classes and in my advisory work in relation to the application of LLMs and SLMs and the ensembling of MOEs, mixture of experts, et cetera, is that people want answers. They want the answer. They want a stochastic system, fundamentally a stochastic generative system, to yield a deterministic answer. They want greater precision. I don't think it's contrarian. I think it's an obvious thing to say, but what I've been pushing with my classes and my clients is you should be using these things to generate not answers, but insights. What's the future of insight? And please don't hit me when I say this. What you really want are actionable insights, because an insight that you can't do anything with, welcome to the real world, doesn't do very much. Actionable insights. What are the parameters of actionable insights? And so, yes, I have degenerated pun intended, into AI for AI, artificial intelligence for actionable insights. That's the narrative spine, the narrative arc I am pushing organizations, if not to embrace, at least to explore.
It's the construct of constant dynamic learning
Yes.
versus outcome-orientated comfort. And I think that's part of the issue. You've got to be more of an athlete in this situation than the prototypical industrial view of the world, which is factory line start, factory line finish. This is a dynamic environment. You have to learn to act within it.
I agree, and maybe it's because I've aged out of a certain level of athleticism that I see more as a coach than as an athlete. Because you have these very talented, instead of, the metaphor I offer, the analogy I offer is you need to treat these models as talent. They're talent. It's how do you get the best value from and with talent with certain constraints and limitations. And I think that is a not just a managerial and technical issue, leadership issue for organizations. Yes, in the next 12 to 36 months.
Michael, thank you for today.